Recording in progress.
Right. Good evening, student. Good evening. Let me start. I just got one message from a student as that some of the student cannot join the lecture due to bad weather. I accept it because I can understand the weather is in Sri Lanka these days. It's not perfect. Ultimately, that we have a heavy rain. Anyway, that let's do this one. And as I said that I will do a revision lecture that once you are physically here. So you are going to be here from 16th of December to see you all physically during from there from 16th, right? So I hope I'm audible. I didn't ask you that. Hope I'm audible. Hope you can hear me. Can somebody confirm?
Yes, we can hear you, sir.
Yeah, again, please confirm because I was muted.
Yes, we can hear you, sir.
Right. Yeah. Thanks. Right. Thank you so much. Right. It's understood well, right? The weather situation, of course. So let me start. And so last time we have started thermal physics part, which is basically heat, and then we discussed what is temperature. And also we discussed what is the zeroth law of thermodynamics. So today I will just move forward from here, and we will discuss the part so-called thermal expansion. අපි අද ඉගෙන ගන්නේ thermal expansion. ඒකට අපි සිංහලෙන් කියන තාප ප්‍රසාරණතාවය කියලා. Thermal expansions. Right. So what happened in the case of expansion? We here consider basically the length and also area and also volume. So in principle, we can say that we have a linear expansion. Length can be expanded due to temperature. And also we have expansion of area and we have expansion of volume. So let's consider only length expansion here. The others are very similar to that one. So what happened in the case of expansion? So you all familiar with this particular situation. You know that you have learned these things during your science grade 8, 9, 10, right? Even in that railway lines, you know that they just keep space in between two joint because we have expansion. At daytime, we have expansion. Right, and this expansion happened due to the temperature. So if you increase the temperature, you can get the expansion of length. So what happened? This expansion, if you described in a scientific way, that so let's say that we have a metal bar with the length L. And this length L can expand by the temperature. Of course, it's little, right? It cannot happen with a large distance. Of course, it is little. We just define this one as delta L. Delta කියලා කියන්නේ හැමතිස්සම පොඩි දිගක් කියන එක. So ultimately that our initial length is L naught, and we have expansion of delta L, we can say due to the temperature difference of delta T. So it's mean that we have initial temperature of theta 1, and then theta 1 change to theta 2. So you have expansion here. So the temperature increase up to theta 2, or change of the temperature. So it's mean that we here, let's consider only the increment of the temperature. So temperature rise from theta 1 to theta 2. Or we can say T1 to T2, right? Then this expansion can be written as delta L, which is proportional to L naught initial length, and the proportional to temperature T change, delta theta. This is delta, change of the temperature. Then we can just define this one, delta L proportional to L naught delta theta, and then we need the proportional factor. Then අපිට ඕන proportional factor එක මෙතෙන්ට දාන්න, because it's a proportional. So we need to say delta L is equal to something. So this can equal just putting the constant so-called alpha. Then this is L naught alpha delta theta, or we can say delta T. This alpha is so-called linear expansion coefficient. අපි කියනවා මේකට linear කියලා කියන්නේ රේඛීයයි, එක පැත්තට වෙන්නේ. රේඛීය ප්‍රසාරණතාවය කියලා අපි කියනවා. Expansion coefficient. The linear expansion coefficient කියලා අපි මේකට කියනවා. එයා තමයි මෙයාගේ ගතිගුණය තීරණය කරන්නේ. So the particular value defined how much this particular length can be expanded once you increase the temperature. So this is different with material to material. Some materials with less coefficient, some material with high coefficient. Right? So this is so-called linear expansion. So hope this is clear for you all. Any questions? මම මේ කිව්ව කතාව තේරුණා ඇති කියලා මම හිතනවා. So the L1 තිබ්බ කෙනෙක්, let's say we have initial one is L1, then it's reached to L2 because you increase the temperature by theta 1 to theta 2. Then we can write the delta L mean L2 minus L1. And then initial one is L1. This is alpha, linear coefficient, expansion coefficient, into theta 2 minus theta 1. So this way also we can write this equation, right? Hope this is clear. Is it okay? Right. 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 So you can write this one. Same time, if you have a question, you can ask.
Recording stopped. Recording in progress.
Right. Hope this is clear. Right. So we have this particular equation. This equation for linear expansion. So as I said that we can define this expansion for area as well as volume. So in that case, we can say this is linear expansion. If the linear expansion coefficient is alpha, then in the case of area, which is so-called 2 alpha, then volume, it is 3 alpha. So this is how we define this one. Now, as I said that due to this one, solids are undergo thermal expansion. And as I mentioned, the railroad tracks and also the bridges have a special joint because of this one. This is so-called expansion joint. These expansion joints which allow them to freely expand and also the compensate in the case of change of length due to temperature. තොර මේ එක්ස්පෑන්ෂන් ජොයින් එකක් තියලා තියෙන එක නිසා ඒකේ රත් වුණාම ඒ දිග වැඩි වෙන එක කම්පන්සේට් කරගන්න. ඒක ප්‍රශ්නයක් නැති කරගන්න. තමයි මේ ජොයින් එක තියලා තියෙන්නේ. එතකොට ඒකේ ස්පේස් එකක් තියෙනවා. ඒ ටික ප්‍රසාරණය වෙනවා. Right? So as I said, the different materials having different values of expansion. So normally, this particular value alpha, as an engineer, if you are doing sort of material related things, you should have to get idea. So you have to get idea when you are selecting the material for your instrument design part. So this is measuring in 10 to the power minus 6 in range. And then this is like we just say this is xy into 10 to the power minus 6. So we measure the length, and this is also length, and this is length. So this one to this one cancelled. So alpha, the unit is 1 into temperature. Temperature නැත්නම් තමයි වෙන්නේ centigrade. So this is a unit of this alpha. So this is 1 into C, the unit. So xy is some values. So in the case of aluminium, which is 25 into 10 to the power minus 6. And copper, which is 17. This is copper. This is aluminium. So it means this value is a little bit large. However, that the materials like nickel alloy, nickel, ඒගොල්ලෝ වැඩි expand වෙන්නේ temperature එක වැඩි කරාම. So in the case of nickel and the mixture of other things plus some other metals, we so-called alloy, nickel alloy. So sometimes a very precise instrument are made by using nickel alloy, and this one is less than 1, something like 0.9 into 10 to the power 6. So you can see that if alpha is small, it means that amount of expansion is small. Alpha කියන value එක පොඩි නම් expansion පොඩි. එහෙනම් මේ expansion අතර කරගන්න නම් ඔයාලා තෝරගන්න ඕන alpha අඩු එක්ක. For an example, if you select aluminium, which is 25, at the same time, if you select iron, which is 12. So in the case of ferrous, this is around 12. So it means that if you use aluminium, so you have twice times expansion than steel or iron. යකඩ වලට වඩා ඇලුමිනියම් පාවිච්චි කරොත් එයාව දෙගුණයක් expand වෙනවා. අන්න එහෙම තියෙන්නේ වැඩි. Right? Is it clear? ඒක මතක තියාගන්න. Right? Okay, then let's do one simple question. Right? This is considering one practical application. Let me show you one nice thing. I'll give you, of course, 2 to 3 minutes for you to write, and you can also search these values in internet, and you can find what you have to understand is that if alpha is large, then ultimately you have a large delta L, right? And so this is what happened, right? Right. So please write this part, and then I will explain you the other one. So same time, if you have a question, you can ask now. මොනවාරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න පුළුවන් දැන්.
Recording stopped.
Right. Let's start.
Recording in progress.
Right. Let me show you one picture, and this is so-called golden grade beach. අපි මේකට කියනවා මේ San Francisco's Golden Gate Bridge එක කියලා. So this is basically 1 mile long bridge, right? If you're familiar with the geometry of United States, and in left-hand corner that we have this type of basically the structure, and Mexico is here, and then this is so-called California, and we have the Arizona here, and also the Nevada here, and then Oregon is here. So this kind of structure is available. Basically considering the areas. As I said that this is so-called 1 mile bridge, mean 1.6 kilometer bridge. A bridge 1.6 kilometer bridge, right? And so here we have ocean, and this ocean is basically moved to the land side, and this is a Pacific Ocean, of course, and this particular movement to the land side, which is a bay, and this bay is so called the San Francisco Bay. අපේ ඔය බෙන්ගාල බොක්ක වගේ අපි මේකට කියනවා San Francisco බොක්ක, San Francisco Bay. And then we have 2 cities in between there, and this is San Francisco city, of course, and then we have another city so called Marine city. And this particular one, we have a bridge. There's a bridge basically connect these 2 cities. So this is one of the most internationally recognized symbols of San Francisco and also California. And this was basically designed in early 90s, and then this is sort of wonderful modern art, and which is a combined design of American Society of Civil Engineers. So what happened in the case of San Francisco? We have a very hot summer as well as the winter season. So the winter temperature is around -10 centigrade, and then this is a hot summer which is 40 centigrade. So this is made by steel. So the linear coefficient of steel is 12 into 10 to the power -6. And this is 1,600 meter long bridge. So in the coldest time, let's say this bridge is 1,600 meters. Now the bridge is exposed to the temperature range -10 to 40 centigrade. So what is the change of the length between this temperature? Right, so you have to find this one. So send me the answers. Right, so once you find this one, send me the answers. I just want to know the length can be expanded due to this temperature difference. මේක කොච්චර දුරට expand වෙයිද? නම් delta L හොයන්න තියෙන්නේ. බලන්න කීයද මේ value එක කියලා. 1,600 meters bridge එකක්. නැත්නම් 1.70 මේ bridge එකක්. ඒකට අපි කියනවා Francisco Golden Gate Bridge එක කියලා. මොකද ඒක gate එකක් මේ තියෙන Francisco මේ පැත්තේ තියෙන්නේ මැරයින් සිටි එක ඒ දෙක යා කරන බ්‍රිජ් එක. එතකොට එයා කොච්චර එක්ස්පෑන්ඩ් වෙනවද කියලා මේක වින්ටර් එකේ ඉඳලා සමර් එකට මාරු වෙනවා. So please send me the answers. If it is not clear, you can ask from me, right? Again, I will explain.
Recording stopped.
Right. So only
Recording in progress.
only 27 students I'll send the answers. Others are still calculating, I guess. Anyway, that what the student did, the value is 0.96 meters. It means it's less than 1 meter. So if you use a 1.6 kilometer length, the expansion due to that 50 centigrade difference, which is 1 kilometer, 1 meter, less than 1 meter, of course, nearly 1 meter. So it's not much, but you have to consider this one, because even very tiny increment of length cause the break of this particular bridge. It is bridge. මොනවාරි ප්‍රශ්නයක් වුණොත් 1 මිලිමීටර එහාට මෙහාට හරි වෙලා වුණොත් බ්‍රිජ් එක කොලැප්ස් වෙන එක වෙන්නේ. එහෙම වුණොත් මිනිස්සු මැරෙන එක වෙන්නේ. So engineers, they have to keep this one in mind. You have to consider this expansion, and you have to consider all the expansion joint here. Overall, it's less than 1 meter, nearly 1 meter. However, might be in the case of this kind of expansion position, it is less than 1 millimeter. However, you have to consider this one, right? You have to consider these things, right? So this is the, these are the things you need to consider when you are preparing devices. So this is clear. So you will do many questions, and you have to contact Miroshan to have your tutorials. So I believe that the batch rep or somebody will contact him to schedule your tutorials, and then please do that one, right? So you have to do many questions, and then you can learn these things, right? Right. And let me consider a very small part of this one and then finish the lecture. It's all about heat. As I said that we discussed about heat, and we are supplying heat to any material. So this is what happened. So we supply heat, and heat is transferred to the material. අපි heat එක දුන්නාම material එක heat transfer කරනවා. Right? එයා heat එක transfer කරනවා. Heat එක දුන්නාම. So in that case, let's say that we have material, and the mass of the material is M, and we supply heat Q. The temperature of the material increase θ1 to θ2, which is so-called delta T. Right? So we are supplying heat. Heat is measured in joule. And once you supply heat, which is Q, an important thing is mass of the substance, which is M. And then you have change of temperature, which is delta T. And there's a factor in here, which is so-called C. This is so-called specific heat capacity of that particular material. The equation so-called Q equal mc delta theta, or mc delta T. Or sometimes people say mc theta. Theta means delta theta. Specific heat capacity. You transfer the heat to a certain material. So it's mean that if you increase the temperature of any material to a certain level, and you can transfer heat, or that you can give heat to increase the temperature. This is what happened. So that is so called Q. එහෙනම් කාගේ හරි temperature එකක් වැඩි කරලා Q submit කරාම එයාගේ mass එකයි දන්නවනම් එයාගේ C දන්නවනම් අපිට එයාගේ temperature එක කොච්චර වැඩි වෙයිද කියලා හොයාගන්න පුළුවන්. So that is all about heat. So then we can define this specific heat capacity, which is so called C, specific heat capacity. C in this manner. If we have 1 kilogram of mass, අපි ඒක 1 කරනවා. Right? So specific heat capacity mean that if you write this one, then this is like C equal. So this is C equal M divided by, C equal Q divided by M delta theta. So if mass is equal 1, if delta theta equal 1, then C is equal Q. So now we can define this one. So how we define specific heat capacity is defined in amount of heat. This is amount of heat, amount of heat amount of heat amount of heat required 1 kilogram of substance or material, raise the temperature by 1 Kelvin or 1 centigrade. Temperature difference එක එකක් වෙන්න kilogram එකක තියෙන material එකක heat එක තමයි C කියලා කියන්නේ. එහෙනම් අපි මේවා කියනවා ඒකක ස්කන්ධයක් ඒකක උෂ්ණත්වයකින් වැඩි කරන්න අවශ්‍ය කරන තාපයට අපි කියනවා specific heat capacity එක කියලා. විශිෂ්ට තාපධාරිතාව මේකට සිංහලෙන් කියන්නේ. specific heat formula එක මේක එහෙනම් C කියන එක මේ විදිහට define කරන්නත් පුළුවන්. Right? Is it clear? මේක තේරුණාද? තේරුණාද? Right. මම දන්නේ කවුරුත් කතා කරන්නේ. Right. Hope this is clear. Right? No question seems to be. Right. So you can write this one. So specific heat capacity is defined as the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 Kelvin, because we are using SI unit. Right? So we can define this specific heat capacity. Right. So you can write this part.
Recording stopped. Recording in progress.
Right. So let's do a very simple question and then finish this one. So let's suppose that we have a material so-called gold. අපි ගාව gold පුට්ටියක් තියෙනවා. So we have a material so-called gold and which is 100 gram. And we need to increase the temperature of this material by 50 Kelvin. අපි ඔන්න material එකේ temperature එක Kelvin 50කින් වැඩි කරන්න හදන්නේ. By 50 Kelvin. So it's mean that let's say we have a temperature of 300 Kelvin and then we increase to 350. To 350. Right. So by 50 Kelvin. And C of gold is 130. So the unit is joule per kilogram per Kelvin. So you need to find Q. The amount of heat required to increase the temperature by 50 Kelvin of 100 gram of gold. So this is the question, right? So send me the answers, right?
Recording stopped. Recording in progress.
Answer is 650 Joule, right? So most of the students send me the correct answer, right? So thank you very much for that one. Right. So with that, I'm going to stop today. So next week, we are going to learn about heat transfer and how heat transfer. It is also around 1 hour lecture, less than 1 hour. So that one I'm going to conduct tomorrow evening, right? Tomorrow evening at I'll send the message 4 or 5 o'clock. I will send that one. Then ප්‍රශ්නයක් තියෙනවා Kelvin Celsius කරන right. Okay. So basically that you need to understand this one Kelvin to temperature. So we consider this is a triple point. So 0 centigrade is 273.1 Kelvin to 273.1 Kelvin. But normally we are not considering this one. So we basically consider room temperature as 27 centigrades, mean that which is 300 Kelvin. So this is how it's normally used in the case of standard scientific method. So SI unit of temperature is Kelvin, right? It's not centigrade, it's Kelvin, right? That is why that in specific heat capacity, we normally define this temperature in Kelvin, right? Change in temperature in Kelvin. But change of temperature is similar even in centigrade. Change even so in the case of Kelvin, which is 300 to 310. In the case of centigrade, which is 27 to 37. So that is 10. But normally we just denote this one in Kelvin. අපි denote කරන්නේ එක Kelvin විදියට. Right? මම හිතනවා ඒක තේරෙන්නේ නැති කියලා. Right? Is it okay? Right. Hope this is clear. Right? So with that, I will stop. And
Recording stopped.
in next time, tomorrow at around at 5 o'clock, of course, I will send the message to the WhatsApp group, and we are going to learn about heat transfer method, and especially this conduction, convection, and also the radiation. So we'll teach this one, and specifically that each and every part having an equation. So I'm going to introduce you 3 equations in the case of this heat transfer method. So with that, so thank you very much for joining, and hope to see you in tomorrow. Right? Thank you.